In the summer of 1994, while living in the mountains of Western Canada, Haramein, after months of following the developments of the Shoemaker-Levy comet, decided to pack his small personal telescope onto his rucksack and scale the closest, highest peak so that he may observe the comet colliding with the surface of Jupiter. Weeks prior to the event, the media, reporting from the astrophysical community, stated that none of the impacts would be visible to the amateur observer, and that these impacts may even be difficult for the high-powered telescopes to observe. Haramein, however, disagreed. To him, the impact of these high-velocity objects, composed of H2O, provided all the chemistry necessary for a fiery show, and Haramein was not about to miss it. Sitting on the summit of Mount Wedge, Haramein night after night witnessed the awesome and spectacular event. In some cases, flames the size of Canada emerged from the impact coordinates, leaving behind enormous black depressions, visible even with weak telescopic capacity.
So one of those nights I was on the summit, and it was just a magical moment. On one side I had low cloud coverage over the peaks that were below me, and I could see the lightning lighting up those clouds. And on the other side I had the sun setting, and the moon was rising, and it was just the most clear night. And I was looking at Jupiter through my telescope, and I started to think of the surface feature of Jupiter and that huge red spot, almost 1.5 times the size of the Earth on Jupiter, that constantly, steadily stays at the same latitude. And I thought, what about that dynamic? Is that staying there for some particular reason? What is forcing that huge vortex of Coriolis dynamics to stay at that latitude all the time? You'd expect that it would dissipate eventually, you'd expect that it would move in latitude, go all over the place, but it doesn't. And I thought, what if that structure on the surface of Jupiter is staying there because of the dynamics of the structure of the vacuum, the tetrahedron inside the sphere dictating that energy event to happen at that particular spot on Jupiter.
Upon his return, Haramein began to investigate. He found that not only did the red spot on Jupiter orbit very close to the magical 19.47 latitude of the tetrahedron inscribed in a sphere, but that many other planets exhibited similar dynamics. Haramein was not the only one to have noted this phenomenon. At the time, Richard C. Hoagland, former science consultant to Walter Cronkite, CBS News, CNN, and NASA, had come to conclude that some hyperdimensional tetrahedral dynamics had to be at play in planetary structures. He noted that not only did the red spot on Jupiter exhibit the appropriate geometric latitude, but that many other planetary energy events were consistent with this geometry. The largest volcano in our solar system, Olympus Mons on Mars, is situated near 19.47 north latitude. Hoagland used this perspective as well to predict energy phenomena at specific latitudes on other planets that were later confirmed by NASA's probe photographs.
So I applied the same geometry to the Earth, and I realized that if you put a tetrahedron inside the Earth so that one point is at the South Pole and the other points are at 19.47 latitude, on the surface of the Earth in the North Hemisphere. And I looked around to see what was there, and sure enough, I found the most active volcanoes on Earth, the Hawaiian volcanoes, exactly at that latitude. And then I went along that latitude and I found the city of Titicacacan, north of Mexico City, to be at that latitude as well, which is quite remarkable. As we saw in the presentation, the mathematics of that city were decoded by Hugh Hollison Jr. to describe the dynamics of a sphere with a tetrahedron in it. And so not only does the city have these mathematics in it, but the city itself on the surface of the Earth is at that latitude that demarked the relationship of a tetrahedron and a sphere. Remarkable.
However, Haramein's model predicted a 64 cube octahedron structure as the dynamics of the vacuum, and thus he wondered if they could be even clearer resolutions of the other intermediary angles produced by this more complex geometry. If so, it would give observational evidence that the structure of the vacuum is a result of the more complex array of an octahedron-tetrahedron matrix. Haramein looked at the bands of both Jupiter and Saturn and was amazed to find how closely these bands obey the angle relationship of the 64 tetrahedron grid. Furthermore, the recent data returned by the Cassini probe confirmed the presence of an enormous hexagonal feature on the north pole of Saturn, first imaged almost 27 years ago and still persistent to this day. The hexagonal structure, which is completely unexpected in standard models, not only obeyed the latitude dictated by the 64 tetrahedron grid, but is fundamental to the geometry of the cube octahedron at the center of Haramein's conceptual model and mathematics. Even more compelling is the recent imaging returned by the same probe of the south pole of Saturn, which in this case portrays an enormous vortex that seemed to be absorbing matter in a whirlpool. The South Pole vortex leads to the center of the planet, as would the double torus dynamic resulting from the structure of the vacuum, as Haramein's model would predict. Our local star, the Sun, is no exception to this phenomenon. Hot bands of high-energy plasma and intense sunspot activity are found to stabilize at approximately 19.47 degrees latitude north and south. Our Sun follows a very regular 11-year cycle in which the Sun periodically flips its poles and increases its radiation intensity. The last solar maximum occurred in 2001, making the following maximum the year 2012. This date is in direct agreement with the so-called solar Mayan calendar and codices, still one of the most accurate calendars on Earth, which predicts that 2012 would mark a change in the Sun's quality, resulting from a much larger cycle where our Sun would transition from the fifth sun to the sixth sun. Haramein believes that these ancient traditions may have been tracking the larger cycles of the position of our solar system relative to the galactic disk. Our Sun is located approximately 26,000 light years from the galactic center and orbits our galactic disk approximately once every 250 million years. However, our Sun rotates along the galactic arm in a periodicity of approximately 60 million years, whereby the Sun crosses the equator of our galactic disk once every 30 million years.